All right, this video is going to start talking about regular polygons and finding the area of regular polygons. This section, part one, is going to be finding what's called the apothem. In a regular polygon, this is going to be a convex polygon with both equiangular and equilateral characteristics, meaning all angles are congruent and all sides are congruent. Circumscribed circle we've talked about in the circles unit. It's going to be a circle that contains all the vertices of a regular polygon. And we'll see that down here. This is the circumscribed circle, and there's a reason we're talking about that. All vertices of the regular polygon are going to attach, creating inscribed angles. The radius, and it says down here, of a regular polygon. Okay, we know what the radius of a circle is. What the radius of a regular polygon is it's going to be the same radius as the polygon's circumscribed circle. So when you find the circle's radius, right here from the center to the circle, that is also going to be the radius of the polygon. Keep in mind that it's going to go from the center to a vertex. That will be the radius. The apothem, what we will spend this video on finding, is going to be a segment that is drawn from the center, just like the radius, except the radius goes to the vertex. The apothem is going to go from the center to the midpoint of one of the sides. So over here, we're looking at, here's your apothem. It will be perpendicular, and it's going to be a midpoint, creating two congruent parts right here. And we'll see that on the next page. And then the last thing we talk about is your central angle. If you look in here, we have all these different triangles, okay? The central angle is going to be right here, or right here, or right here. We're going to be, the first step we're going to have to do to find the apothem is to find the central angle. So we need to remember our central angle formula. In a regular polygon, since all sides are congruent, all angles are congruent, when drawing in every single radius, all the radii, all the central angles will be congruent. So it's 360 degrees all the way around, and we divide it by the number of sides, which is going to be n. So we'll use this formula first and foremost when finding the apothem. Now let's go ahead and take another diagram here, and let's identify these different parts. In square FGHJ, we have inscribed, it's inscribed inside circle K. So circle K is going to be the circumscribed circle. We're first going to name the center. We'll find the center of the circle right there, and it's just a point K. We're going to go ahead and name all the radii. We're going from the center to a vertex of the square. So we're focusing, also looking at, it goes from the center to the circle. This right here does not go to the circle. It does not go to the vertex, so it's not the radius. So we have segment KJ right here and segment KH. Make sure that we have these segment bars above it. Now the apothem, from the center, perpendicular to a midpoint. It does not touch that circumscribed circle. It ends at the midpoint right here of a side, and it will always be perpendicular. So we have segment KL. We're going to name a central angle. So if we look right here, it's not going to be angle GKL. I need you guys to understand that the central angle is going to go, it's going to be formed by two radii right here. So we've got angle GKH. Make sure that we're seeing how that central angle goes right here. Do several more in a little bit. And we're going to find the measure of this central angle. Well, the central angle formula that we discussed, we're going to take in the number of sides is 4 in a square. So we're going to take 360, divide by 4 to get 90 degrees. And this is what we're going to be doing first step for the next 6 problems. So while finding the length of the apothems, we're going to round our answers to the nearest tenth. Okay, so starting off with the first problem, we need to talk about the steps. There are 3 different steps. The first one, you always need to find your central angle first. What ends up happening here is we don't have a central angle because it's formed by 2 consecutive radii. So we're going to go ahead and draw in segment AE so that now we have a central angle. The central angle is this entire length. So to find the central angle, we first need to see that n, number of sides, is 4. We just did this, right? We know it's going to wind up being 90, so we divide. And so the measure of angle AEB is 90 degrees, right here. The next thing we need to do is we need to take this larger triangle here that we just found the central angle for, and we need to break it down and cut it in half. So what we're going to do is we're just taking this portion right here. And we pull this triangle to the side. Let's take a look at what this looks like. Okay, we have our 90 degree right here. We have 5 written right here. Your apothem is going to be segment EF. So that's what we're going to find. The apothem is represented with a lowercase a. Now, to find the angle up here, what happens is this altitude right here is going to split the central angle in half. So we're going to take this 90 degrees, and we're going to take half of that angle, and half of 90 is 45. So we need to find the apothem. We have the hypotenuse. What we can do here is we can either use trigonometry or we can use our special right 45, 45, 90. We're going to want this rounded to the nearest tenth in this case, so let's just go ahead and use trigonometry. Right here is our reference angle. We're going to notice we're using our hypotenuse and our adjacent sides. So this is going to give us cosine. So we're going to take the cosine of our angle, 45, equals adjacent, which is our missing, over the hypotenuse of 5. Now if we solve this by setting up a proportion and cross multiplying, we're going to find that our apothem is going to equal 5 times the cosine of 45. Because we are doing trigonometry, please make sure that your calculator is in degree mode, extremely important. When we plug this in and we round to the nearest tenth, your apothem is going to wind up approximately 3.5. Okay, find the central angle, draw the half that triangle to the side, take half of that angle, and then figure out how we're going to solve it. Okay. Next, we're going to go ahead and look at this 5-sided shape. We do have a pentagon. Now, what we're going to see here first, starting off, as we talked about, let's go ahead and just find the central angle. N is 5, so we're going to take 360 and divide by 5. We need to go ahead and make sure we draw in that other radius so that we're finding this central angle. And we're going to find that the measure of angle AFB will be equal to 72 degrees. Now when we pull the triangle to the side, half that triangle, right here, triangle FGB, we're finding the apothem. We know that we need to take half of the angle, which is going to give us 36 degrees. We need a side. So what's going to happen here, we're given the side measurement of 6. So if this entire side right here is 6, we need to understand that that apothem hit the midpoint. So this is actually going to end up being 3. So we cannot use anything other than trigonometry. Trigonometry is going to be a must. Here is our reference angle, and we're going to notice that we are using the opposite and adjacent sides. Opposite and adjacent is tangent. So let's go ahead and set this up. We have tangent of the angle measurement 36 is equal to opposite of 3 over adjacent A, or our missing. If we set this up for a proportion, I taught my students shortcuts about where the missing number is. We'll go ahead and do proportions here. We cross multiply this direction. We're going to wind up with A times the, sorry, I'm getting all confused with my colors here. A times the tangent of 36 equals, cross multiply the other direction, we get 3. We need to divide both sides by the tangent of 36 so we can get A by itself. Again, please making sure that you're very careful that your calculator is in degree mode. When these cancel, A is going to be approximately 4.1. Let's go ahead and move through. Please pause it if you need to. First step, find that central angle. We have 3 sides, so n is 3. 360 divided by n. We draw in the other radius to get this central angle, the measure angle ADB is going to equal 120 degrees. So we'll go ahead and pull half this triangle, triangle DEB. And since we pulled half the triangle, we want half the angle, which is going to be 60. We are given the radius here of 4, and we're going to find our apothem. You can use your 30, 60, 90 if you would like to. I'm going to go ahead and just stick with trigonometry. We go with trigonometry. Here is our reference angle. We have our hypotenuse, and we have our adjacent side. So adjacent hypotenuse is going to be cosine. So we have the cosine of 60 equals adjacent A over the hypotenuse of 4. Then we could do our cross products here. And we're going to find ourselves needing to multiply 4 times the cosine of 60. We plug that into the calculator. We're going to find that A, our apothem, is 2. Pause and rewind if you need to watch it again. Next problem, central angle, first step. We have a total of 1, 2, 3, 4, 5, 6, 7, 8 sides, so n is 8. We divide 360, and right here they've already given us the 2 consecutive radii that we needed. So we're finding this central angle. So the measure of this angle, we don't have a name for it, so just say measure of angle equals 45. So let's take out one of these 2 congruent triangles here. Here's our 7 on the hypotenuse. The apothem is right here, okay, right here. And we need to take half that angle. And half of 45 is going to give you 22.5. So now we can go with our trigonometry. Here's our reference angle. We're using our hypotenuse and adjacent again. If you're using trigonometry to find the apothem, you're always going to have adjacent. So we set up cosine of angle measurement, 22.5. And go ahead and write over here the cosine. That's what I did during trigonometry. This will be equal to adjacent, or missing, over our hypotenuse, 7. Again, this is going to be a cross multiplying. So in our calculator, we plug in 7 times the cosine of 22.5. Rounded to the nearest tenth, your apothem is going to be approximately 6.5. All right, we got 2 more. There aren't any tricks to the last 2. It's the same thing over and over again. It's a great thing about this. 6 problems in a row, just doing the same thing. All right, let's go ahead and find that central angle. We have a total of 1, 2, 3, 4, 5, 6 sides, so n is 6. 360 divided by 6, this measure, the angle measure was going to equal 60. Let's take half that larger triangle here. Here's the 90, here's the 3. This is going to be the central angle, or half of the central angle, I apologize. So we need to take that 60 and make sure we have half the angle of 30 degrees. Looking at where the apothem is is not going to change places. Just look at the triangle where we have it, okay? And we're going to notice here, if I use, again, you can use your 30, 60, 90 if you'd like to. Okay? If you prefer 30, 60, 90, set up that table. But I'm going to go ahead and stick with trig. Here I have my hypotenuse and I have my adjacent again. So we're going with cosine. It's same thing over and over, looks like. So we have the cosine of 30 degrees is equal to adjacent, or missing, over the hypotenuse of 3. Our cross product, the apothem will equal, now we're going to do 3 times the cosine of 30. Calculator in degree mode. This will wind up being approximately 2.6. All right, last one. Same thing, same steps over and over and over again. Central angle. And draw in the other radius. Find the central angle. Let's look at how many sides we have. Lots. So let's be careful counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N will equal 10. So we find the 360 divided by 10. The measure of the angle end up being 36 degrees. Let's take part of this triangle here. This guy out. The apothem here, the reference angle, we need to take half of the central angle. And we'll end up with 18 degrees, tiny angle. Now for the other side that we have, it's going to be a lot like what we had up here on the second one, where we're given the side length, we need to cut it in half. The side length is 12. So we need to cut that in half for these two congruent parts, and that will be 6. So we have to use trigonometry on this one, no other option. So here we do not have our hypotenuse, so it's automatically going to be tangent. Making sure that our apothem will always be adjacent, A and A, so the 6 is going to be opposite. Let's set our function up. Tangent of angle measurement of 18. This will be equal to opposite, 6, over adjacent, the A. We set this up to do our cross product. We're going to see here that we have A times the tangent of 18 is equal to 6. This is going to be our division trig. Divide both sides by the tangent of 18. Calculator in degree mode. Your apothem will come out to approximately 18.5. So again, great thing is just 6 problems, nothing changed other than the numbers and what we were looking for. It wasn't, oh, now we're going to make it a little more difficult. We need to understand finding the apothem because we move on to part 2, finding the area of these. We're going to need to understand how to do this already so we can go through a little bit more quickly. If you need to, rewind and rewatch, or you can search other area of regular Polygon videos.